Today we'll be working on mole conversion, so let's review what we have learned. When we do mole conversions, you should have out your mole island right here. And there are three equivalences or three conversion factors that you will be using. If we want to go from grams to moles or moles to grams, we are going to use molar mass. 1 mole is how many grams? And I remind you where to get that number of grams from the periodic table. Okay, now this is an island, this is a life raft, and it can flip. Okay, so whether moles or grams is on top in this life raft, you have to figure that out by setting up the problem. And we'll do that in a moment. If I'm going from things to moles, there are 6.02 times 10 to the 23rd things for every mole. And remember, this can flip as well. If I want to find out how many liters of gas there are, it has to be at STP, which is standard temperature and pressure. And you can add that right on here, standard temp and pressure. And if at standard temperature and pressure for every 1 mole, that gas will occupy 22.4 liters. So since it's a gas, you can think about a balloon being 22.4 liters. That would contain 1 mole. And again, this can flip. Now, some people get confused. They say how many grams are in a mole and how many atoms are in a mole. Remember, when you see grams, this is something you weigh on a scale. Things, that's a counting number. So that's the difference between the two. People mix them up because how many starts both questions sometimes. So in order to do this, our first thing we have to do is know how to get molar mass if we're going from grams to moles. So let's do a review of our molar mass. Nitrogen gas is N bonded to an N. That's why it's N2. So I have N plus N, and that would be 14.01 grams per mole plus 14.01 grams per mole, and that's going to equal 28.02 grams per mole for nitrogen gas. Ammonia is NH3, so that's NH. So you would have to add N and H 3 times. So where do I get these numbers from? They're from our periodic table. So nitrogen is 14.01 and hydrogen is 1.01. So you will add all that up to get the molar mass. So now we are going to go through our mole conversions. One step would be going to 1 island, and you would have 1 conversion factor. If I wanted to go from grams to number of things, I can't go this way. The sharks will eat you, and there's no conversion factor. So you have to convert everything to moles. The first thing to know is if you don't have moles, you got to convert it to moles. Okay, so we are going to convert it from grams to moles and then moles to things. Since I went through two life rafts, there are 2 conversion factors, and we'll do an example of both. So when we do this, we start out with this number here, which is scientific notation, and I'm going to go through a review of how to do that properly on your calculator. So show all your work using dimensional analysis or you don't get any credit. Your unit should contain the measure, which is grams, atoms, or liters, and the chemical. This is going to become very important in stoichiometry so we don't get lost. Remember, your conversions, we put our given number from the problem, get rid of the given units we want, and go to the first units that you want, and then put in this conversion factor. Okay, so how many moles, that's where I'm going to, of magnesium is in 3.01 times 10 to the 23rd atoms of magnesium. Okay, so my question mark is here on moles. I'm going to moles, and they give me this many atoms of magnesium. So I'm starting here, which means my conversion factor will contain these numbers. Which one goes on top? I'm going to figure that out. So my path is to go from my given, which is atoms, right? So let's circle your givens. And then our question mark is how many moles to moles. Okay, so I'm going to write down the atoms as my given number first. 3.01 times 10 to the 23rd atoms of magnesium. And I don't want atoms of magnesium. Whoop, whoop, whoop. Okay, so here I am at atoms of magnesium. How do I get off that island? Well, I need to put atoms of magnesium at the bottom. Okay, and why do I do that? Because they cross out. Just like your variables in algebra, they cross out. Okay, so that's why we put them on the bottom. And where am I going to? I'm going to moles of magnesium. And so now I have my conversion factor. Moles and atoms, okay? So 1 always goes with moles. It doesn't matter if it's on top or bottom. When you see moles, you put a 1 there. And since I'm going from here to here, my other number is 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd, which is Avogadro's number of things in a mole. Now, in order to put scientific notation in your calculator, if you hit 10 and if you hit times and 10, 9 times out of 10 you're going to get that wrong. Okay, your calculator doesn't understand the order of operation when you put this in. So you need to use an EE button, which is an exponent button. That's here on this calculator. On a different calculator, it's down on the bottom. Now, if it says a 10 times 10 here on the bottom only, you can use that. This one, this 10x with the log, that's for log numbers. That is not exponent. So if you're hitting log, you're going to get things wrong too. So this one has the exponent down here. And the calculator most people buy is this guy right here. Okay? And yeah, Texas Instruments 30x. That exponent button is EE, this little EE here, and that's your second function, EE to the 23rd, okay? So let me do this problem with you. What we have here is we have 3.01, and exponent means times 10, okay? So when you hit EXP or EE, say times 10, and then just put in the 23rd, and then we are going to divide it by 6.02 times 10, your exponent button, to the 23rd, equals, and we get 0.5, okay, but that's not exactly correct. 0.5, but notice I have 1, 2, 3 significant figures, and I only have 1 here, so I have to add zeros at the end to make it 3 significant figures. And then my atoms of magnesium canceled out, and my units are moles of magnesium. Canceling out these units tell you the units you have left. And what was I solving for moles of magnesium? How many moles of magnesium? So that tells us that we did our problem right. Okay, so here is our answer, correct sig figs and correct units. And this is a 1 conversion problem. We only went through 1 life raft. So now I want to do an example of a 2 conversion problem, okay? How many grams, this is our question mark is grams, that's where we're ending, is in 4.2 liters of oxygen gas. Okay, so they give me 4.2 liters, that's where I'm starting. And they want us to find how many grams. This is my end. So I have to go from liters to moles, right? I can't go through here, the sharks will eat you, and then moles to grams. That is a 2 conversion problem, so we are going to need 2 parentheses here. And our path is to start at liters, to go to moles, and then to go to grams. So under liters, where I start, oops, wrong one, sorry. We're down here. I'm going to start at liters. I'm going to go to moles, and then I'm going to go to grams. Okay? So here's my liters. I write down my given number first. So here is my given, and I'm going to write 4.2 liters of oxygen gas, and then whoop, whoop, go into moles, and then whoop, whoop, go into grams. Okay? So I'm going to get rid of my liters of oxygen gas because this is the units I have. Only the units go down here, and where do I want to go to? I'm going to moles. Right? Liters, how do I get off liter island? I put it on the bottom. And where am I going to? I'm going to moles. I put it on top. Okay? And then I'm at moles. Do I want to stay on mole island? I do not. How do I get rid of it? I put it on the bottom. Moles of O2. And where am I going to? I'm ending in grams. So that's the next island I want to go to. So grams of O2 goes on top. So now I've set up my units only. Liters of oxygen cancel. Moles of oxygen cancel. I'm at grams of oxygen. That's what I'm solving for. And now I need to put in these conversion factors. So I'm going from liters to moles. 1 goes with moles, and 22.4 liters go on the bottom. Okay? And I know that's the right way to set that up because I've already set up my units. Now I'm going from grams to moles, and where do I get these grams? Molar mass from the periodic table. And 1 goes with mole. Okay, so moles is on the bottom this time. It's flipped, but you can see 1 goes with the word mole, so I'm going to put 1 there. And now I need to determine the grams of oxygen gas from the periodic table. And here's a common problem. This is O2, so it's OO. That's what O2 is. So I need to multiply oxygen, or not multiply, add oxygen plus oxygen, 16.00 grams per mole, plus 16.00 grams per mole, is going to give me 32 grams per mole. Okay, I should have 2 zeros there, but let's keep it clean. Okay, so 32 grams per mole. And now I've set up my conversion. What do? We multiply by what's on top, we divide by what's on the bottom, multiply by what's on top, divide by what's on the bottom. And I'm going to give you a little tip here. I see a lot of people trying to multiply the top, multiply the bottom, and then divide both. That is correct. I'm not saying it's not, okay? But I get a ton of calculator problems when people do that. If I just have you put it in the calculator like this, I have a lot less calculator problems. So I start with 4.2, multiply by 1. You don't have to do that. Hit equals between everything. Divide by 22.4. Hit equals. Multiply by 32 times 32. Hit equals. And then divide by 1. Okay? And you're going to get that 6 is our answer. I have 2 significant figures, so 6.0 grams of O2 gas. And that is our 2-step conversions. What I like people to do is put your finger on where you start, put your finger on where you end, and then find your path. Wherever you are, you get rid of it by putting the units on the bottom and put the units where you want to go on top. Units on the bottom, units where you want to go on top. Multiply by the top's number, divide by the bottom, hit equals every time you do that. Okay? And we do have 1, 2 significant figures in our given. Our given is always going to tell us the significant figures that we want at the end of the problem, not these conversion factors. So I have 2 significant digits, and here I have 2.